The funny story I always tell is a few years ago I was camping at Glacier National Park. Anyone been there? You should. Utah's beautiful. Utah's gorgeous. Glacier, pretty awesome. Sitting around the campfire, somehow the conversation came to the point where I said, yeah, I heard my voice carries. 3 campsites over, someone goes, sure does! So I'm in the right profession, obviously. Also, before we get going, I have a little tradition that I do. I need to prove to my boss, who's in Florida, I come from Seattle, that I came to Utah, not just to come to Utah in the wintertime, although the snow isn't quite ready yet. Not sure why y'all didn't do that, but it's okay, I can come back. I need to prove that I worked. So if you all could smile and wave. Let me get everybody. Here we go. There we go. Okay. Awesome. Thank you. So, what we're going to talk about today, we're going to talk about a journey that...
Wait. Real quick. When we were emailing with Paul, he said it's been a while since you guys talked about vCluster. So that meant you had talked about vCluster before. So before we get into it, raise your hands if you have heard of vCluster. Yeah.
Okay.
3 people.
Thank you.
Yeah. Shut up, Brandon. We've got 4 people that have heard of vCluster. Brandon heard about it at Strap Tank 15 minutes.
Yeah, I've heard of it.
Cool. So that's super helpful context. I'm Benjamin. I'm on the sales side, covering Southern California. This is my second time to this meetup. I used to work for Cast AI. I was here a couple years ago, so some familiar faces in here. Scott's gonna really run the show. Did we already talk about why Tim's not here?
So I was about to jump into there, but it's good. So we were gonna have a guest, a friend, speak with us. He even had, if you notice, this space looks really lonely right here because he was on there. He threw out his back and couldn't get approval in time to talk at a public group. So who works for a big corporation who needs to get approvals for things? Yeah, so you know how that goes. So we're gonna be here, we're gonna try to tell, or what we decided to do, because this all came about in the last 4 hours, we're gonna tee up his story, hopefully that he comes to another meeting, because Tim is based here, he works at that big red building over here, this big building with the red sign on it. And so Tim will tell more details there, but we're gonna tee up his story and hopefully tell a little bit about GitOps, how GitOps helped Adobe, but then also possibly how vCluster helped in their GitOps process. And so without further ado, I think, is that everything we had to cover with Tim?
Yeah, I think so.
Okay, cool. So just to level set with folks, who's familiar with GitOps? Everybody's pretty familiar with GitOps. Okay, so just to level set for folks in case you haven't, because I've definitely been in your shoes. I've sat in a room where everybody else in the room held up their hand and I went, okay, yeah, sure, I know about whatever you're talking about, sir or ma'am. Just in a sense, GitOps is the way you define infrastructure and application configuration using Git. Git is the source of truth. You're not going to be using UIs anymore. You're not going to be using any kind of other configuration engine except for the fact that your configuration is kept in your repositories, so you have the history, you have an automated processes built off of your commits and your pull requests and things like that to deploy, to test, and to run your applications. There's a topic that I will hit briefly, mainly because I find it interesting. Who's heard of the rendered manifest pattern?
I've never heard of it. I can guess what it is, though.
Okay, tell me.
I'm going to assume it is generating the final result rather than middle layers, right? We actually took this approach really early. We generated from Helm, and then the Helm was sent to Argo, and we really quickly realized that was horrible.
Why was it horrible?
Because what you see is not what you get.
Right.
Yeah, so for a long time, we have a repository full of thousands of YAML with no further processing required.
Which, if you looked at that YAML that you were trying to render things off of on the fly, do you have a history of the things that you've done? Which, isn't that what Git's supposed to do?
And you can't trust that Helm upgrades are going to change things, and you don't know what one small impact is going to mean to everything that's rendered. It's really bad.
Really? Yeah. Once I was introduced to this idea, a light bulb went off. I was like, oh, right. This is exactly what you're supposed to be doing. I'm going to show it a little later. At the end, I'm going to show a demo using the rendered manifest pattern and also the fact of using a config repo separated from your app repo, your app code repo. So we're gonna show that here in a little while. I don't believe it applies to Adobe Story, so I'm not going to go into it just yet. But what I do want to do is essentially, oh yeah, this is what I was going to talk about. The fact that we're going to have a couple of the architecture I want to use to think about, something you can use when you're processing your GitOps flows, is you need tools that do your CI/CD process, which is going to be testing your code before it goes into production, and then you're going to have tools that are continuously deploying your applications out to the world. And so in this case, here, I'll be talking about GitHub Actions and Argo CD. Argo CD is kind of the de facto standard, although right now I think Flux is sort of taking over. Who's using Argo CD? Who's using Flux? Okay, so it's still Argo CD. Everybody's talking about Flux, but Argo CD is what we're all still using. With Adobe Story, Adobe had a fascinating internal system that they were building. Benjamin, do you know a little bit more about that?
Yeah, I mean, Tim will be back to address all this stuff, to tell you guys their full story. So this is just a preview, but I mean, you guys are all familiar with Adobe and their scale, and they've been using containers since 4 years after Docker was announced, and then they started developing into Kubernetes just before the pandemic, and then through the pandemic, they migrated successfully to Kubernetes. And then just over the last 5 years, they went from managing dozens of clusters to hundreds of clusters. This is across all, I mean, they've got about 10,000 developers in the company, right? And so they've got all of the environments, dev, test, stage, prod, and then, I mean, raise your hand if you even feel comfortable guessing how many applications Adobe writes and runs internally and then sells.
That's just because I work there.
Yeah. You currently
You
work
have
there?
a good idea.
Oh, you work with
He asked
Tim?
me to come down, and then I didn't know he was.
Oh, you're on the networking side. Sweet. Do you want to talk to the story? Okay, cool.
He doesn't have the.
Correct me if I'm,
doesn't have the clearance either, so yeah.
I do know, but
Yeah.
you're doing a good job. So.
correct me if I misspeak,
I actually
so.
feel more comfortable that you're here because you'll be like, no,
Yeah.
that's great.
Call us on our BS, but we're not gonna talk too much about it. We're gonna let Adobe tell their own story. But the main point here is that, at scale, Kubernetes, which is built for scale, can be challenging, right? And I've been with vCluster for about a whopping 6 weeks, but the reason that I joined, I've been in the Kubernetes space for a few years, the reason I joined the company is because there's kind of this fundamental, tendency problem with Kubernetes, that you can do namespaces that don't offer you isolation, or you can manage, hundreds or thousands or hundreds of thousands of clusters. Neither of these are great options. And so, that's why I leaned in. That's why Adobe was leaning in. And this, I have no idea what this is showing, but I do know that it's showing a lot of scale. So this is long-running requests on the API server, and it's, over a 6-hour period gets up into the hundreds of thousands. Anybody else hitting their API server at that level?
Besides him,
Besides,
he's on that team.
No, I've never really looked at it. Probably.
Yeah?
okay, all right.
So you're also operating at a massive scale, which is
Maybe not that scale, but quite a bit.
Yeah.
Yeah. Okay.
Great.
Sweet. And so, like I said, preview of coming attractions. Tim will be back in the new year, and we'll do the full talk that we had planned. But with that, I will get that dumb sales guy off the stage and let you guys keep going.
All right. What I want to do actually is, before I dive into because we are going to hit vCluster a little bit, I actually want to talk through that demo that I was previewing there, because I think that's fun, that's interesting. We're all developers, right? We all want to look at code and see how, we want to see more YAML, right? Okay. I tried to show excitement, and I know that we all feel the same. Okay, so what I'm going to do is I have an application that I won't even lie about this. There's a guy in the back of the room that wrote this application. Rob, thanks, buddy. So Rob wrote this demo application that's a .NET application, runs inside of a cluster. But what I want to do is I took it and I made it my own. I have an application that covers a topic that is near and dear to my heart. I love hamburgers. Who loves hamburgers? That's right, and so do I. And so I built an application that tracks where are my great burger places that I've been to. Because I love to go into a town and find that burger joint that's just unforgettable. If you ever go to Seattle, Dick's Drive-In, that's the one I tell everyone. Everyone needs to go to Dick's Drive-In and get a deluxe. It's fantastic. Deluxe fries and a chocolate shake. It's like walking into an In-N-Out and saying double animal style and chocolate shake. Can't not say it. So, in this case here, I have an application that's going to track this information for me. And this application is running in a cluster on DigitalOcean. And so I have that cluster here, and it's, I want it to basically continually deploy when I make changes. I also want it to run tests for me before I actually push those changes out to the world. And so what I have here is I have my code running locally. And is there a way to get this out? Will this kill the meeting? It will not. It will not kill the meeting? Okay, great. All right, so I have my code here. Let's do this here. I have an application. It is fairly straightforward in the sense I have a back end, I have a front end, I have E2E testing. And so in this case here, we're gonna make a small change, and then I'm gonna have a GitHub action. That's what we have. Let's fix this real quick. Better, yes? Yes. Yeah. Word to the wise. If you're presenting in a room where the projector is going to be in a well-lit room, light is always better, even though anyone who works in this state, obviously nobody here works in this state, right? We all work in dark mode. But presenting, you want to present in light mode. All right, so I have a GitHub action. It's essentially taking a cluster, it's going to spin up, it's going to make a connection to DigitalOcean, and then it's going to essentially take my application, my changes, what I'm going to do, and it's going to run some tests on them. So what I want to do here is take my application here. We are not in Vancouver anymore. All right, I get it. Utah is a big place. This isn't Salt Lake City. So where am I? If I'm gonna say best burger places in
Lehigh.
Okay, I'll go with Lehigh. Okay, Lehigh. Should I say Utah County?
Utah County is the wider one.
I mean, it is the county, right?
It's Lehigh.
I am in Lehigh right now, I know that. So, okay. I'm gonna say Lehigh, because we're gonna put our favorite burger place in Lehigh so you can tell me where to go. But I'm gonna make that change. That change is fairly basic to our UI.
You should clarify, though, that Vancouver is the Washington one, not the...
Hence why I had BC on there. Right.
Because I just learned that there was a Vancouver, Washington.
And they're on opposite ends of the state,
And
right? Vancouver, Washington is down by Portland. Vancouver, BC is up in, American City. I love Canada, I do. I was just referencing a Simpsons joke. I wasn't trying to disparage Canada. So, but Homer did say.
I'll edit that out.
Okay, sorry Canada, we love you. Here we go. And so here we go. I'm going to say Lehigh is my change. Just say Lehigh. I'm going to commit this change. I should probably point this out. I'm already in another branch. Okay, so I'm going to create a pull request. So my new location. And I'm going to commit this. The reason why I want to run this without explaining what it's doing is because it takes a second for it to run, right? So we'll let it spin and do its fun stuff while I'm explaining things. All right, it's gonna sync changes. I'm gonna come over to my repo here. I'm gonna come over to my pull request, Lehigh, or Utah County, or Thanksgiving Point, or yeah. Create that pull request. And because I have this GitHub action set up on my repo, it'll hopefully pick up here in just a second. Yes, it does. Perfect. Okay, so what it's doing now is it's going to be taking my configuration I have here. And I have a setup here where we're going to be setting up a URL that we want to call it PR, and then we're going to grab the number of the PR that we're going to be testing. And then it's going to be also, I love VS Code, but this stuff is just insane. So, okay, like that, right. All right, so I have my PR URL, I have my production URL. I'm gonna come here, I'm gonna kind of slide over some of this stuff, like creating our containers, pushing our images up to our registry, grabbing our images, making sure they're running for us inside of our clusters. I'm going to connect to DigitalOcean. That's important here. Authenticate. I'm going to connect to my cluster that I have in DigitalOcean. And here I'm going to install vCluster. Here, why would I want to install vCluster? As Benjamin was talking about earlier, vCluster is a way of running a control plane inside of a pod. That way it makes it so you can have multiple clusters running inside of a Kubernetes cluster. So in our case here, I have my cluster running on DigitalOcean, which, how long does it take to spin up a cluster, even on DigitalOcean, which is fairly fast? How many?
Minutes at best.
How many?
10 minutes?
Ish, 10 minutes. So that means if I was running this test, it would take 10 minutes to spin up that cluster. Plus I'm spending, the last one I spun this up, it was $75. So you're spending $75 to get another cluster to spin into there. But you're spending that time. Plus, now you have to think about okay, I have resources inside that cluster. Say like I have ingress controllers. Say I have cert managers that I want to test. I have to install those and configure those and get those into my cluster as well. In the case here, what I can do is I can actually take that host cluster that we have on DigitalOcean. I have my ingress controllers. I have my cert managers. They're already there. I can just sync them into this virtual cluster, and that virtual cluster spins up as long as it takes a pod to spin up. In this case here, I'll come back to my test. Come on, GitHub, I clicked on that. There we go. And we've already spun past my container being created because we're running our tests right here. I created my vCluster back here. I have my vCluster, and I named it PR15 because I want to track where my tests are happening. So I can say, hey, I can look at this version of my code. This version is pull request number 15, or however other identifier I want to use. In this case, I'm using that number. And so I can even come here, my automated tests, see the long stuff. What's happening? We have our tests here. Our tests ran. Automated tests passed. That's fun. Okay. So our tests pass. If this was a talk about tests, I would go into the tests, but this is a talk about GitOps. So if you guys want to look at the tests, we can do that. But I was planning on just kind of talking about the overall flow. So let me know if you want to go in that direction. In this case here, everything's green, everything's happy. And I left my vCluster up, which means I come up here and grab my URL above there. PR15. I can take it and share it with my team and say, okay, we ran this, the test passed, this is what it looks like. The test data was Dick's Drive-In, because I'm biased towards that place. But I can see, okay, this looks right. Best burger places in Lehigh. Lehigh is spelled correctly, I believe. And everything looks right, the button's in the right spots. So I can sit there, but I can share this with other people on the team. I can even come here. If I say kubectx, to look at my context. Okay, I'm in my DigitalOcean cluster. I could say get pods. Okay, I'm not going to zoom in that much. I got to have at least some. Let's see here. And here, I'm in my host cluster. So I'm in a regular DigitalOcean cluster. I just broke my darkness rule. And but you can see here, I have my production running in its own pods. And I also have my PR at the bottom that's not on the screen. Thank you all. Ta-da! Testing PR. However, if I wanted to say share this cluster, share the cluster that production's running on or that the test is running on, I can look at my virtual clusters and see I have my virtual clusters. I can say vCluster connect testing PR 15. And then, that's really low down there, my bad. And then I can come here, and then I run that same command of get pods, and now all I see is the back of everybody's heads in the front row. There we go. And now all I see are my deployment for my backend, my front end for my core DNS, because that's inside of my virtual cluster. So I have more boundaries than just a namespace, because now I have access to the ingress controller, the Nginx ingress controller that's installed into my DigitalOcean cluster. And then I can use that to create ingress. We already saw that I got into PR 15. Or PR 14, oh, 15, 14's here, haha. That was me testing that one. And so then I can also look at it has the same infrastructure. I can come in here and say burger places. This is my production here. So I have my production there. So I have those two running in two different virtual clusters, but running on that same DigitalOcean host cluster. Now, to jump out of vCluster for a second, I want to go back to that. Actually, do I have any questions so far? Please, Paul.
So, what is the default conductivity between your vClusters and it's called the native cluster, so that you have least privilege, but also then, let's say you don't want to spin up databases within there, but you want to be able to have access to, or you may want to spin up databases in there because you're changing the schema and you didn't want to mess up something else. How easy is that to configure, and what is the least privilege rules? What are they, I should say?
Right, so in my slides, actually, this is great. You're like leading the witness. This is perfect. So in this case here, how the architecture works is the virtual cluster, vCluster, has what's called the vCluster syncer. It replaces essentially the Kubernetes scheduler. And then in here is how you decide what is synced with that host cluster. So in my case, with the test and the production environment that I had, I said to sync ingress classes. Sync the ingress class so that it's grabbing from the host cluster and pulling it into the virtual cluster. In the cases of the other resources you were talking about, you would define those here. You would configure the syncer. You would define them with what's called the vCluster YAML. There's a vCluster YAML you pass to it. So you'd say, in fact, I can show that.
But when you are in the vCluster, you don't get to see those external resources. Is that correct?
Right. So when you're inside the vCluster, I didn't see that I had Nginx already there, but so that's something you have to communicate with the people there, right? So you have to say it's like here's your virtual cluster, and you have access to your ingress class there. In fact, I think if I'm in my so I'm inside my vCluster right now. I could say kubectl. You all can help me. Is it list CRDs? Get. New. So get CRD. No resource fan. Hold on.
kubectl get dash resources.
Yeah.
Thank you. Okay. Get dash resources.
Yes.
Get, what is it?
Space resources?
Space resources. Yeah.
Is what it is.
Thank you. Come on.
What?
Just try CRD.
What? What?
Just CRD.
Just CRD?
No, it's
CR.
no, it's CTL.
CRD.
Oh, CRD?
This is
API
a,
dash resources.
yes, it's a root subcommand of
sorry.
kubectl.
So it's kubectl.
Has to be your role.
kubectl API dash resources.
kubectl API dash
It's a
resources.
subcommand. Right off of the root.
Bam.
There.
There, you can see, you can get visibility into what you have. Two, I believe. Next is here. Yeah. So yeah, there's still a communication that happens between you and the
When you
manager.
deployed into the vCluster,
Mhm.
you had an ingress route or resource, kinda?
Yeah. So in this one here, I can come here and look at my config. So I pop over here and look at my configuration code. In fact, I will come here. This kind of leads into what we were talking about before with the two different repositories. In this case here, I had my GitHub action running on my front end and back end code, but then I also have my config here. And inside this config, I have an ingress controller defined right here. So I have an ingress, it's using Nginx, the Nginx ingress class. And then I have my placeholder values that are in this particular branch, in this main branch inside my config file or config repo. And then these get switched out. When I'm running that GitHub action runs a sed command, a cd command on this file, looks for this, and then replaces it with one of those values that we saw. So we saw one of those URLs that were passing through. It finds these and then replaces them into the file that we're actually gonna render. But remember, I was talking about the rendered manifest pattern that is that's actually, what's the word, endorsed by the folks, the GitOps governing body, the people that decide what GitOps is and things, people at Acuity who also maintain Argo CD, the Argo project. They talk about the rendered manifest pattern. So in this case here, I have my placeholder values. They're always in the main branch. They're always going to stay placeholders because you need to have a spot that has your template values. So I have my front end URL here. And then up here, yeah.
I'm gonna finish that up and then I'll ask you a question.
Which one? Okay, yeah. And then when we're creating our images, we can also label our images with our git SHA, actually is what's happening here. That's it.
The config is the source.
This, in the main branch, it's the
So
source.
are there sub branches here?
There's other branches that I'll show you here in just a second after the question.
So there's no inherent scheduler in vCluster? It's like- So how does it appear to the real scheduler? I'm assuming that it's doing, the real scheduler is doing the scheduling and layout.
The host cluster is doing the scheduling. So it syncs, what it does is it syncs back to that host cluster. And on that host cluster, if we see it, if I come here, okay, I come back out here, I now see all my pods again because this is in the host cluster. This is the DigitalOcean host cluster. And then all the virtual clusters are seen as pods. They're seen as their own entities. So I can kind of have this high level view of all of my different virtual clusters that are running inside. But each one has its own API server. So when I connect into those, I'm isolated from the noise that's going out in the host cluster.
Who's making the scheduling decisions?
The host cluster.
The host cluster.
Okay.
Yeah.
And
So-
the layout, I don't think is being enforced by,
Layout.
well, where things run, or does that even matter in a virtual?
Right, so the host cluster, yeah, it's like all of the virtual clusters are running in this boat, and the boat still controls things, but you're basically providing tenancy isolation to the folks in the virtual clusters, so they can have enough room to get what they need done, but still have the benefits of what's going on in the bigger
It's
cluster.
Kubernetes to root or jail, right?
Well,
basically.
Yeah, you can kind of relate it to like a virtual machine and a hypervisor. That's probably a really good comparison.
Okay.
Is the hypervisor is your major main cluster, and all the virtual machines are your pods that are running your vCluster.
The decent
Think
comparison.
about it. It's not perfect, but it's close.
It's not perfect in the sense that like with
What
the
I was asking for is just a mental model.
Yes. No, it's exactly. You relate it to something you know
Right.
and say, okay, that makes sense. That's honestly where the name virtual cluster comes from. Like vCluster, it's kind of it's a great product. The name kind of confuses people sometimes, right? Because it makes people think virtual machines. Like we were just at KubeCon last week, and a lot of the times I say, oh no, it has nothing to do with virtual machines. There's no virtual machine involved. That's KubeVirt. KubeVirt has its thing. It's doing its thing.
So is vCluster a API proxy, or is it got its own data plane? Is there an etcd behind each one of these?
There's an etcd behind each one of these. Yes. It defaults with a SQLite because default SQLite's a lot more lightweight to run and to spin up, and like it's that testing, it's okay to run SQLite, but if you're gonna run this into production, you don't want SQLite.
So the sync options that you had in the CI/CD before, those are essentially saying every time the API server sees you create one of these things, create it on the root and then create it internally. And that, like I assume that's what's happening there.
So what's happening there is like I already had to have that DigitalOcean cluster made. So I already went into like the DigitalOcean UI and like created a cluster and did a thing because I had to tell GitHub where to go. So in this case here, right here, I create so up here, I install DigitalOcean, I authenticate, but then I had to tell it, this is the cluster that I'm gonna be shooting at.
But I'm specifically talking about the sync options there, so
Okay.
that helps. If you scroll down just a little
Yeah.
bit, that helps. So, secrets, config maps, blah, 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 name all the things. Everything other than pods, I'm gonna assume by default stays isolated within the vCluster. But then, like pods obviously have to get shunted off because they need to go on a real cluster with real nodes eventually, because that's the only way things run.
The pods are actually running, so it's all done with, essentially I say they because I'm not in engineering, right? They, essentially what they do is they use what they call virtual namespacing. So they give the pods a different type of namespace, which is kind of this truncated, or this super extended long namespace. So the pods are actually all there, but you can see them inside of the virtual cluster, but yes, you can also
Sync out. But that's the only thing you get by default probably, and everything else, these other syncs are
these
synced.
other things, yeah, so
Oh,
these,
and also these other kinds of things.
yes. So like by default, I don't get ingress.
So if you listed config maps, and you happen to have them in your app, you wouldn't see them in the host by default.
You would if, probably.
Okay.
Yes, I think so on the config maps. I know so on ingress, I know so on secrets. Because with secrets, that's kind of an issue, right? You need to be able to have your secrets that you set, but then also have them being readable when they're in your virtual cluster. So you need to be able to set them and read them in your virtual cluster and in your host cluster, because when you're,
TLS.
yes,
They did it
exactly,
for TLS. I'm
Exactly.
sure they did it because you can't do ingress routes.
right. So in this case here, yes, so I specified in this case, when I create these virtual clusters, I'm grabbing this information from that host cluster. And then, yeah. And then there's my sed. So in the sed here, I'm going through my configuration file, my manifest essentially, and replacing it with values that are mostly inside of my repository. My secrets that I set, so like the Docker URL, I already set that inside of my repository. But then like the GitHub SHA, that's unique with every single commit that's coming through. And then also, my environment variables that I set here, and then we're gonna replace them inside of my config file that I have here. So where I was going with the config file, we were talking about this before, is we have these branches where on main, I still have my template values. However, I also have a render prod and a render test. These are my rendered manifests. That way I have a history of my manifests that are running inside of my application. I know exactly what's gonna be running. I can run this particular file all by itself whenever I want to, and I can run whatever version is running, whatever I needed. So in this case here, I can say render test. I see my image ID rather than my templated values, but then importantly, I also see my URL there. These are branches that you'll never plan on merging to main. In fact, don't, because that messes up the whole thing. So you want to keep these separated. They're going to be running in parallel for the existence of for the existence of the application. But you do this, you have this structure right here that I was talking about, because your app code and your configuration code, they have different life cycles. This is going to be updated and changed at very different times than this will be, and often by different teams. So you'll probably have different permissions running for each of those different repositories. So having them separate is generally a good idea. So in this case here, we have everything. We've talked about everything in our GitHub action, how that creates our CI/CD or our CI process that does our tests and then deploys, and then now we have our Argo here. Argo CD is running. I have my burger places, Argo CD. And in here, all of you have run Argo, most of you have raised your hand when you ran Argo CD, but essentially this is what it looks like here. When I'm looking at my production cluster, this is still my virtual cluster. I'm able to connect my virtual cluster to Argo CD so that I can have it and deploy it out to production. And then when I make my changes and merge to main, they will push out to production. Yeah. Cool. And then just a couple of different ideas, just wanted to share before I close. So essentially each pod, as we talked about before, each virtual cluster has its own control plane, and it has its own etcd node, or its own etcd data store. We already kind of talked about this one in detail. The idea that we're finding, that we've discovered, so vCluster's been around since 2021, I think. In fact, I think Lucas came to this meetup back around then. Lucas is the CEO, and yeah, didn't Lucas come out here? Yeah.
I think it was Lucas, yeah.
Yeah, and so back when they first started, tenancy, the idea of tenancy was like, wait, we need to provide a way to make something a little bit more isolated than just traditional namespaces. So they basically said you could have traditional namespaces or traditional clusters. But then in the middle, they just said vCluster, and that was it. That was all. Because that's all they thought about at first, and all they provided. Now, we've learned it's much more than just a single option. It's more than just a light switch. It's what we call a spectrum. There might be situations like in this case where we were testing things where you're okay with sharing CNI and CSI and having shared resources with a shared node situation, but then you may have another situation where you have say customers running in production with production data or production processes, and you want to keep everything specifically isolated even down to the node level. Then we found that we should provide something called private nodes, which essentially makes it possible so you can virtually separate nodes for your customers. That way, if you say you have customers and you have Coke and Pepsi in your same cluster, they're not going to be colliding with each other. And then why not traditional clusters? Traditional clusters are fine. They're just expensive, and then you're wrangling lots of different objects rather than just having them all contained in one spot, and then also big, clunky, and things of that nature. So that's kind of my sales pitch on that particular point.
So I'm questioning,
Please.
in your first column there, high node utilization under traditional namespaces, what are you saying there? Is that true?
So with traditional namespaces, what it's saying here with high node utilization is the fact that it's fast. There's no overhead, right? So you're able to use a cluster that's going to utilize any number of nodes, and by default, it's the default Kubernetes setup.
I see utilization differently.
Okay.
Okay.
Yeah.
All right.
How do you see utilization? Just for like,
Well, it's how much you're using versus capacity. It's
oh, okay, yeah.
like, how close are you to getting to?
Well, so yeah, you're utilizing all of the, so yes, in this situation, you're able to utilize, get to all the nodes, right? So
Nothing
you're,
in traditional namespaces helps you there.
Well, imagine you
well,
swap
it's
that.
just default is what I'm saying, but yeah, go ahead.
You're swapping that with wasted space, right?
Yep.
Traditional namespaces, very little wasted space, because everything just jams it on any node that they can fit.
Mhm.
All the special like scheduling rules aside,
Yeah.
right? Just if you just throw stuff at a cluster and you don't do any scheduling rules, it will use the nodes as much as it can. And it's why on the other ones, you start to get to private dedicated, like, it's just for you. Literally, we can't put stuff on there from other places because those were for you. So if you choose this option, you're choosing to waste compute capacity
Yeah.
to gain privacy.
I was just looking for, will this help with the utilization gap? Because we had another Kubernetes meeting where we spent a bunch of time and we learned that we're not unique in this regard, is that most Kubernetes is getting what utilization?
13%.
Yeah, it sucks. So that's what it's like, does this help that gap?
So
Go.
So on the private nodes, one of the things that's cool about private nodes is that you have the control planes all on one cluster. Where the nodes are can be any place you want them. So your control plane could be in EKS and the worker nodes could be in GKE or on-prem or however you want. And what we've done with private nodes is rolled in auto node. And if any of you guys are Amazon users, that might sound very familiar to auto mode, which is their managed Carpenter. And so we've rolled Carpenter into private nodes. Now you can use Carpenter on any environment that you want. So that's where you'll improve your utilization and auto scaling and all of that is where we're focusing. The other side to this is with that architecture, you're able to dynamically attach capacity as you need, and so you can be a little bit more conservative at the outset because these things scale up in seconds instead of minutes or whatever. And so there is a story around utilization, and where people are really getting excited about vCluster isn't so much on the CPU side as it is on the GPU side. And so we've been partnering heavily with NVIDIA and working with some of the neo clouds like CoreWeave and some others to use exactly these capabilities to improve the utilization. But what we're not going to do is help your developers set their requests appropriately. Like, that problem still will exist. If they're being too conservative and requesting too much compute, you're gonna have waste, which is where a lot of that 13% utilization comes from. Hope that was helpful.
Looking at this, it's like, a list of good things and a list of options. And auto nodes is the only one that has a check for every good thing. You were talking about like, vCluster used to be one thing, now it's a spectrum. Why is it not just auto nodes if auto nodes has all the good things?
Auto nodes right now only works with private nodes, and so what's not shown here is an operational overhead.
Okay.
Operational overhead is gonna be very low on
other ones don't
shared
have.
nodes. Yeah, right. So as you move closer to traditional clusters, you do get these benefits, but the trade-off is that that's more care and feeding that DevX DevOps is gonna have to do.
No, thank you. Great. Yeah, we kind of covered this already. And then, yeah. So, yeah, in conclusion, I mean, essentially thank you. That's it, right? So, yeah. Thanks, y'all. Great conversation. You in the back?
You rig your virtual cluster into Argo CD. Was that in the GitHub Actions?
Yeah, so with Argo CD, that was not involved with the GitHub action. That was something I had to do by hand because I'm using the open source version of vCluster. vCluster at its core is open source. Everything you saw me do is the open source version of vCluster. All this stuff on that spectrum that I was talking about, a lot of this other stuff, like auto nodes and things, mainly all of that, is on the paid side of vCluster. So, but if you pay for vCluster and get a paid license, you can actually get a super slick integration with Argo CD that has a GUI UI that lets you connect. However, what I did is I have a situation where I can figure out I got the IP address for my virtual cluster. So essentially what I did here, if I say services, I have my ingress controller for my whole cluster, but then also I have my load balancer for, I have my service for my production, not that, sorry, too much going on. I have my external IP there, and so I can hook this up to Argo CD so that I can make it so that I can run this particular cluster. So in this case here, I have my clusters, and then I have a cluster here that has that same IP address. So it's able to grab that IP address from
Did
that.
that happen after the line in the middle of your GitHub Actions, before you flipped the screen? Like, how did it, or were you reusing a virtual cluster you'd used before?
In this particular case, production is a virtual cluster that's not being created and destroyed in the GitHub action. So that is where the paid version of vCluster comes in. That's handy, is you're able to more easily connect to Argo CD. I don't know if you can do it ephemerally in the middle of a GitHub action. I haven't tried it, but I would guess those types of things are probably easier to do inside the paid version. Do you have experience? Yes.
It's just a Kubernetes object to connect to this and
Yes.
update it, so you can just do that. So like it's a cluster object.
So you used Argo CD for
Secret.
production, but you didn't use Argo CD for your PR branch, right?
Correct.
Right, but he could have done it that way.
I could have, but I was showing two different ways to do things. Yeah.
That's actually how I edit them and display cluster data all the time, is because it comes from Argo CD directly. And you can just get that information right out, and then you can use it to connect to those clusters too, because it's right there in that information. It's a good source of truth.
Cool. Yeah, Paul.
So, maybe two different contexts on the question. So you have the open source version, and you have the paid extensions or features. You find a different positive individuals or companies or whatever that do different things in those areas, or is it across the board? I'm trying to understand my head. Like, we have a great GitNext team and GitOps team and all that here. And I'm just trying to think, okay, so where would I use this? Would I use it for just testing? Would I isolate my testing stuff? Would I do true multi-tenancy in the product and use this? And if I did that, where would I slide over to the paid version? I guess I'm just trying to say, where does this all fit?
I can tell you what the alternative is, because we do it, right? So the alternative to having isolated control planes is one big giant control plane, right? Monolith, microservice, one big control plane, many micro control planes. And when you've got one giant control plane, you have to have an iron fist on naming uniqueness. You have to have really tight controls and in oftentimes explicit checks and guarantees. Like, we have a whole suites of validations on our end to say, hey, you can't call that thing that because this thing calls that thing that. And we often don't let people name anything, because if we let you name something, you'll stomp over it by other things by accident all the time. So like, if you don't have the isolation of control planes, you need really, those templates, those manifests don't get to be simple anymore. They always have to be templated, because you always need to jam name uniqueness into them no matter what. And you can do it, but you have to have a more centralized management of a big central gatekeeper of uniqueness guarantees across things. So I can totally see the value, because you can just say, I don't know, you don't need Helm. You can just have some YAML files, and you don't need to generate unique names for an app when it's deployed 20 times because it's deployed in 20 different clusters, quote unquote. And we just happen, it does, vCluster is doing some uniqueness when it makes the pods, obviously. But most of the time, you don't need that because it's in isolation. So like, I can totally see the value because I'm doing it without it, and I can tell you it's really tricky.
Yeah.
And you have to have a lot of manual checks and guarantees about just stuff stomping each other.
How do you deal with CRDs?
Very difficultly. It's really hard. It's
Paul wanted one, like, what's the process for him to get one?
it's
hard.
It's doable, but CRD is applied across the entire cluster at once. So like making a new CRD is actually pretty easy. Maintaining a CRD as it changes versions and data structures across time is actually really, really, really hard.
Right.
So you have to just be very meticulous about your changes. That's what we do right now.
That's the story with software tools across the industry, right? Everyone's like, oh, I could write that. And I used to work at GitOps, and everybody would say like, oh, I could write that, in a weekend. It's like, yeah, you could, but maintaining it.
Yeah, exactly.
Yeah, exactly.
Me too.
Exactly.
So I wasn't familiar with vCluster before coming here, but, so you say there's an open source. Can you tell me about the governance on that, or is it under CNCF, or?
It's a CNCF project. It is not a CNCF open source project. So we are CNCF certified Kubernetes distribution, but we aren't part of the project like a KubeCon. We're not in the project pavilion, right?
So your company controls the open source version too?
You control the open source version, yeah, of vCluster. We do have a CNCF project, but that's not vCluster.
Okay, so a vCluster. So are there outside contributors to this project?
Yeah, absolutely. It's just we're the maintainers. So all of our maintainers are our engineering team. But yeah, there's absolutely external contributions.
But you get last call.
Absolutely.
You get to say, which is not true once you turn over to CNCF. Turn over to CNCF, the community gets last call, not you.
So we actually have another project that is called DevPod, local development environment, pretty rad project. We don't have the bandwidth right now to maintain it, but the community is just like peppering us. They're like, we still want this, we still want this, we still want this. So we need to figure out a solution. It's probably going to be to hand it off to CNCF to basically say, hey, industry, community, please manage this.
And to go back to your question, right, I think you're kind of honing in on the dev test use case, which is what we were born out of and is the key problem to solve. But that whole spectrum, that's our last 12 months of development as our customers have been adopting it and driving it. And so other customers, their bottleneck is the, like, when they commit, then they have to spin up these clusters to do all this testing. And they're just sitting around. They're just idle. So that average 13% utilization, I'd be curious how much of that is testing clusters that just sit there hot, waiting for tests to come through that have to mimic prod and get no load whatsoever. Since these spin up and spin down so quickly, they fit in there. We see people wanting to get leverage back from the hyperscalers, where if you're locked in on AKS, then it's not non-trivial to move to one of the other clouds. If you're doing vClusters in vanilla Kubernetes, you're not coupled to anything, and so you get some leverage back, some portability back, running on your on-prem data center and bursting into the cloud because the architecture enables that. So there's a lot of these use cases, and you did mention templating, and that was something, one of the big cloud data warehousing companies that you would all know. Their big challenge is they're kind of taking the same approach as you. So CRDs are a no-go. They'll say no to developers for months on end if they want a CRD, and then if they're still hammering for it, then they'll sit down and determine how best to handle that, just because it's a pain in the neck. But when they realized all of those YAMLs that Scott was showing, those can be constructed and built out as templates. And so all of the variety of customers can go and have either, I want to do everything, or I want you to do everything and everything in between. But they know that it's fully compliant. They're specifying the manifest, the shapes of it and all of that stuff. So they have all of their security, their compliance, and they're taking advantage of their savings plans. They're prioritizing the correct RIs and all of that stuff into it. So, but then the developers have the autonomy that they want, and they get a whole lot of throughput. So, and then, as we're working with folks like Adobe looking for more, like, okay, this is really cool, but you've just opened up a can of worms with networking. And so we just launched vCluster VPN to enable all of this stuff to be wired up and connected a whole lot more easily. So it's very much customer-driven development to build out those features.
Do you have, I'm assuming, you could make this in like Kubernetes as a service. Do you have people that are doing like a fly.io type, where they spin up a little individual and then you pay them?
Oh, I haven't seen, that's kind of what the neoclouds are doing.
Right. I was gonna say, the reason why I was nodding is because, I've heard of people using us in production where essentially it's the folks that are wanting to share GPUs, right? They buy, they're like GPU farms, and they have these big clusters, because the best way, that's what I was pulling up actually while Ben was talking, was this diagram here. So in this case here, the best way to utilize GPUs is the schedulers, like Kai Scheduler, Run AI, those type of schedulers that work with GPUs, they want to have essentially access to all of them, or access to many of them. And so to get the best utilization out of them so they can divvy up the work, you need to put them all in the same cluster. But then if you put everybody in the same cluster, now everybody's in the same cluster, right? And now you can either have a team that does all the crazy meticulous stuff to make sure that everybody stays not running into each other, or you could use vCluster inside of that host cluster, which this provides that isolation across the teams and the workloads, and then you use that scheduler to provide that sharing of the GPUs. So we do see that there's some folks that are using us in that production scenario for that, which is fascinating, right? It's a whole different space that wasn't there in 2021.
I'm assuming that billing is a nightmare in a system like that.
Yeah, for us or for them? Yeah, I would guess. I don't know. I'm curious how their billing is.
Not in the GPU space. That's not real money. That's not real money.
Because those dollar amounts are real, right?
Well, it all still always boils down to a pod on a node for an amount of time.
Yeah.
So whether you have a cluster with a bunch of pods that are all uniquely named because you meticulously named them, or you have vCluster making pods that are auto-named for you, you still just build pods on nodes for
You know the total bill, but if you work for a company like I did, it has tenant A and B, and you want to do charging to those two entities.
I think cube costs and some of those things, if you label things appropriately,
But
they'll do that.
how much
I'm learning the story of how to label them properly.
Anyway,
Yeah.
keeping track of all the GPUs a model uses, good luck with that, sir.
Billing's the worst.
Well, KubeCost has got all of that. You really can do it, even with vCluster.
Yeah. No. Yeah, I'm not intimately familiar with KubeCost, so.
Well, I don't work on the cost efficiency team at Adobe or
And
anything.
I didn't either, but and eventually it came to my doorstep. It's like,
They're telling me that.
eventually somebody has to pay the bill, and it gets ugly in a company.
See, that goes back to the use case argument, because basically you want to lower costs, you want to be able to track those costs. Our cloud efficiency team is looking at vCluster for that reason.
And I think it does probably provide help.
Yeah, it does. I just don't know to what extent. It's great extent, but you have to also tool it up in places.
Well, I think it'll lower your total cost.
It will.
Yeah.
It's not a debate. It's a matter of where you want to get it.
So just to follow up on
Sorry, thank you.
the
Sorry.
Adobe question.
Go
So
ahead.
what was the end result? Did they reduce the number of clusters they had, or big cost
We're
savings?
still in the process.
Still in the process, okay.
Things have become more efficient, I think.
There's an evaluation. I don't know where Tim's at, but I know that I think he just finished it. To be fair, I think that's why he's waiting for approval.
Yeah.
Plus, I don't actually know.
Okay.
So admittedly, I don't know where we are, except for that I know he was near the end of because he was asking me lots of questions about vCluster and Argo CD, which is why I'm here.
Yeah.
And then he's like, I heard him say he hurt his back. I apologize. I didn't realize that he hurt it that bad.
That was in the thread that we had with him today. He said that he threw his back out. So.
Yeah, he's doing something on the weekend. Anyway,
Yeah.
basically, he's evaluating it for our data center services. I don't know beyond that, and even if I did, but until we get legal approval.
Hence why, right? Like, hence why we couldn't really dig into
Right.
it either.
Well, and the only way you save money is by having fewer VMs, right? So if you're on that spectrum that you had before, and you're on the left side, you're on the most, that's the cheapest it'll ever be. It never gets cheaper than the leftmost side of that spectrum. So I'm gonna assume Adobe's somewhere on the rightmost side, which was, we need security boundaries and we have to make more clusters, and more clusters is more money. And so any step you make leftward is less money, as long as it has that node utilization checked.
And like, without, like, let's take Adobe out of it and answer
Well,
this
actually,
in
before you
your
do
own
that-
abstract way.
Before you do that, depends on the use case, I think, too.
Yeah.
Because we probably have a mixed bag across the whole middle section there.
Well, I've worked at companies where even without separate clusters, we spun up and used Affinity to have, here are some nodes for this workload, just for the sake of billing. They will be half empty, but the billing team preferred clean lines for billing purposes. So the nodes were half empty all the time, and something like this might let them.
For the use case that we're talking about here, it's not so much cost savings as it is cost avoidance, because we're talking about on-prem data centers. And so the evaluation was completed successfully, and the question was not, will I have to buy less plates? It's, I have this plate, can I get more, can I put more onto it? And the answer to that is yes. And so the expansion of the data center will be postponed for them. But in all of our customers, you know, it's starting with us with a solid use case, whether it's, you know, templating or CRDs or whatever it is, and then it expands because of all of these other benefits. So.
You said, yeah.
Yeah, the GPU thing seems really compelling. Like, I think we might need that because, like, you know, GKE doesn't have enough GPUs for us.
Right.
So we go to other places. But when you start taking a bridge,
Okay, cool.
when you start taking all these different clusters managed by all these different companies in all these different places and treating them as one thing, do you basically like shoot yourself in the foot in terms of reliability by like, now it looks like I have one thing, but I actually have a bunch of different regional things. Like there's a reason that AWS don't let you do that, right? They don't let you have a cluster that spans regions, and that's so that you don't lie to yourself about your isolation.
Right. Because, yeah, you don't want it.
So it's like one thing for training or whatever, but like, do you have people like doing that level of abstraction for inference and then actually being able to run like a high 9 service?
That I don't know. Refer to my comment. Yeah, that's a great question. I'm gonna actually write that one down and take that one back to the team because I don't know.
I think the vCluster is further subdividing. It's not a tool for connecting disparate clusters. It's a tool for
Absolutely.
I think he's saying it was, because you have a control plane over here, and then you have worker nodes over here, and vCluster lets you treat them
clusters
all.
gotta exist within one Kubernetes cluster, right? So like, you can't like use vCluster to say, here's Kubernetes cluster, here's another Kubernetes cluster, here's vCluster that uses both. Sure. Right. Just gotta be, here's vCluster that further subdivides one.
Theoretically, that was the federation was supposed to do, right?
No, but this set of slides, but for the private nodes architecture.
It's actually, I
Oh, you took it out.
ripped those out of that one. So just a moment.
Because like multi-cluster and making multiple clusters look like one is a totally different like ecosystem. It's a totally different space.
But it seems like there was a flavor of that in here.
Yeah, so these are separate clusters, and but what I don't think anyone is doing, like, it would probably work fine for training to have these cross-region, but for inference or for anything that's serving to users, I wouldn't recommend that. I don't know if anybody's tried, and I'm not the person you should ask, but just on its face.
And is it possible to have like, say, tenant B, one of those purple lines go to the other side?
Not
I'm
in
gonna
this.
assume that tenant
Not
B
in this
cannot
model,
span
right.
2 clusters.
The guarantee here is that
Oh, I
the blue
see.
nodes are for B, and B only uses the blue node.
Right, so this one is associated with this node pool, it has its own pool, and then this one can be, we're basically showing you can either be dedicated to a pool or to specific nodes.
Yeah.
But this is how you get around node limits on the providers, if you're getting up to scale and you need, you can continue to attach here and build huge clusters that just wouldn't be possible otherwise, because they limit that stuff, so.
I don't think there's any problem with any of this, I'm just like trying to define what the tool does and doesn't do, like, this makes sense to me and solves the problem.
So I've got a question for you. Knock, knock.
Is there?
GP.
Uh-huh.
That's not how knock knock jokes work.
You who?
Yeah. Thank you guys. Did you have anything else?
I didn't. Thank you all. You were a great audience, and look at any questions. We also have stickers if you want stickers. If you like stickers, we have stickers.
Thank you both, and I think, maybe?
Bring Tim in. We set it up. Now Tim just
Pictures there?
yeah.
That'd
We
be
can
great.
talk about his details.
Thank you so much.
Thank you all.
Stop the recording now?